we shall be looking at ordinary differential equation, ODE, ordinary differential equation. In ordinary differential equation, the first concept is separation of variables, separation of variables. Now, in separation of variable, it is likened to the process of collection of like terms in ordinary algebraic mathematics. For example, you are expected to solve du dt is equal to 2t plus 5 into u squared minus 4. Du dt equal to 2t plus 5 into u squared minus 4. When we get this, considering the concept separation of variable methodology, all we do is to gather the like terms. Du and u squared minus 4 will meet, and that will give us, in the solution process, that will give us du divided by u squared minus 4 is equal to 2t plus 5 multiplied by differential t. Then, when you have du over u squared minus 4, because this is coming here as variable gathering, so by the time the variables are culminated together, the u variable here and the t variable here, you introduce integration. The methodology of solving in separation of variable technique is integration methodology. It is integration that supports the separation of variable technique. Now, the general particular solution when you are given IVP, initial value problem, is also application of integration. So if it is general particular solution, that's the end of the answer, it is same. So what you do is you integrate both sides. And this breakdown, because this is difference of 2 squared, that gives you integral 1 over u minus 2 into u plus 2 multiplied by differential u is equal to integration of this will give us 2t squared over 2 plus 5t plus arbitrary constant c, because t 1 plus 1 over 1 plus 1. Then by the time you use partial fraction methodology for this, you have the whole of this, when translated into partial fraction, gives you a over u minus 2 plus b over u plus 2, which is equal to 1. So therefore, by the time you cross multiply, we'll be having a into u plus 2 plus b into u minus 2 equal to 1. So at this point, take note too that this one is expected to be over u minus 2 into u plus 2. So as to break it down in partial fraction process to give us this format, because as this multiplies this, it cancels this, and this is left to multiply a. U plus 2 cancels this to give you u minus 2 to multiply b. This is what you are saying, equal to 1. So in all of this, when we say let u equal to minus 2, then a will disappear, then b can now give us a result. So that is to say minus 4b is equal to 1. So b is equal to minus 1 over 4. And if b equal to minus 1 over 4, let also apportion u as 2, so as to nullify this value. This value has been nullified initially by minus 2 to give us a zero function. So the next process is to substitute 2 to nullify b to get an a. Then when that is done, you discover too that a is also equal to 1 over 4. And this is substitution methodology. Inserting back into this format, we'll be having integral of 1 over 4, the a now, all over u minus 2 minus 1 over 4 over u plus 2 all into differential function of u, which is equivalent to t squared plus 5t plus c. Now, when we integrate this normally, we will be getting a value, and that value gives us 1 over 4 into natural log of u minus 2, because if you differentiate this, you get 1, multiply this, you have this. Now, also minus ln of u plus 2. And this will be equivalent to the value at this other side, which is being reflected here as t squared plus 5t plus c. Now, we can further this work here. We can further this work here by giving the symbolic breakdown of this simplification by multiplying all through with 4. When multiplied by 4, natural log of logarithm will be having ln of u minus 2 over u plus 2. Take note that the natural log is covering both. The natural log is covering both. We are taking a single natural log out of the 2, and we are now having this relationship. That is to say, 1 over 4 that is here, we can multiply through by 4, and that gives us 4 into t squared plus 5t plus c. Of course, if the bracket is opened in mathematical sense, it gives us natural log. Perhaps you can introduce absolute value so that you get a real number, plus 2 is equal to 4t squared plus 20t. Now, 4 multiplied c will be 4c, but in ordinary differential equation, 4c could give us a. You can say let 4c equal to a. Yes. So take note of the symbolic presentation of a, which replaces 4c in that expression. So, like I have just told you, we gather the variables. After that, we introduce integral sign. Then subsequently, we go into the application of partial fraction. The partial fraction helps to break down the denominator so you can easily integrate. After the breakdown, a is 1 over 4, b is minus 1 over 4. Substitute and integrate, you have natural log of u minus 2, natural log of u plus 2, with 1 over 4, which was existing here as a factor. You can factorize it from here. Take note, it is going with du. That guarantees integration, because there must be a differential function to integrate.